Now that we've gotten this far, we want to create the API for the blockchain node side. We'll go to project, then this time go to blockchain_server.go. We'll be writing our code here. We previously created getChain, and I'd like to add on our code from now below this. First, we'll be writing func bcs blockchain server. The method name is transactions followed by HTTP response writer, then rec HTTP request. Then we'll write switch, then rec method. Next will be case followed by HTTP method get. We'll be writing method get later on. This will be followed by case HTTP method post, and with this, let's create our transaction. And for other cases, we'll write log, print error, invalid HTTP method. Next, we'll write header and have status bad request displayed. From now, let's work on this section for post. We'll write decoder, then JSON, new decoder, then rec body. We'll take this and we'll use JSON streaming for our struct. We created block transaction request previously, and we'll take this and write error followed by decoder decode and pass in our address. If error and if it's not nil, then we'll write log printf and display our error. This will be followed by IO write string, then W string utils, JSON status, then fail. And last line for this section will be return. Then we have our T validate. When we can't do this, then we'll write error missing fields. We'll create a log like this, and all we have to do is copy the 2 lines from above and paste. With this, we're able to obtain the data that is needed for the transaction from this web server to the blockchain node. Next will be public key, and for this we'll use utils public key from string to return the public key and followed by tsender public key. Now our tsender public key is returned to the public key for our Go struct. We'll do the same for our signature. We'll write utils signature from string followed by tsignature. Now we'll go to our projects and to our blockchain.go. Here, we should have our add transaction that we previously created. I'm going to scroll up a little, and we have our add transaction here. When we input information like this here, we can generate our transaction. Instead of calling this directly, we want to add one function. So let's copy this. And before add transaction, let's rename this and write create transaction. And within this, we'll write is transacted, followed by BC add transaction, which we have down below. We're going to include our sender, recipient, value, sender public key, and S to our add transaction. All this will be followed by return is transacted. It's like we're calling this directly, but when we create this, we can sync a transaction to another server. So in cases like this, we want to call on this create transaction method. Right now, this may be confusing, but before add transaction, we want to add create transaction, and we want to call this method from our blockchain_server.go. Now we'll write bcs.getBlockchain and bring our struct that we were working on just now. This will be followed by is created, then bc create transaction, t sender blockchain address, t recipient blockchain address, t value, public key, signature. This is the transaction that we want to create, and using this signature, this transaction will be verified and created. So all we have to do is send this to our client side. Now all we have to do is write header, add content type, then application JSON. Here we'll declare byte and use if to input variables into our byte. If we aren't able to create, then we'll want write header, HTTP, status bad request. Then comes utils, JSON status, fail. If that isn't the case, that means we were able to create. So we'll write header HTTP status created. And then in our message, we want to say success. Then this is our last part. We'll write IO write string W string M. This is how our post looks, and let's also write our section for get, which is for when we display our transaction in our API. We'll write header, then add content type, application JSON. This is followed by BC, BCS, get blockchain. We'll pull up our transaction, so transactions followed by BC transaction pool. Right now, we don't have any, so let's create one. Here, we'll go back to Blockchain Go and scroll to the top. Once we're at the top, let's add on to the section below New Blockchain. We have our new blockchain here. Underneath here, we'll add Func BC blockchain and add transaction pool. We want to return our slice for our transaction, so we'll write return BC transaction pool. Once we're done with that, we'll go back to our blockchain_server.go and we see that our error is now gone. We pulled up our transaction, so all we need to do is JSON Marshall, then struct, then transactions, blockchain transaction. When we want to display this with JSON, we'll write transactions. We also want to display the length of our transaction, so we'll write JSON length. Then we'll write transactions, then transactions, and for our length, then transactions. This is followed by IO write string, W string M. So we've gotten this far, and what we just created for this transaction section, we need to register this handler. This is our section for our handle func, but we're going to add a line for our transactions and also write transactions here. Let's restart our server and now access our wallet server and restart that as well. We've started up two servers. Our wallet server and blockchain server have been started up. Now on the left side here, I've brought up our web UI. In the middle, we have our URL for transactions from our blockchain node displayed. This is 0005000/transactions. And let's click enter. Transactions is empty and length is 0 is what's displayed, and this refers to the section that we just wrote. It's this top section right here with our method get. And now we want to first send our transactions from our web UI to wallet server, then to the blockchain node, and see if we get a response. For example, let's write a random address and say the amount is 1.0. We'll click on send, then OK. We get the pop-up message, send success. In this current situation, we want to see if our transaction is included or not. We'll refresh and we do see that our transaction has been included. The sender is this blockchain address and that matches with this blockchain address. Then address BBBB is a random address, but we confirm that this has also been included. Our value is 1 and length is 1. Now let's change this to C and change the amount to 2.5. We'll click send, OK, and we'll refresh our screen. We see two transactions displayed and the information included in the transaction matches our original input. We entered our information in our web UI and this information has properly been passed on and verified and stored in our blockchain node side. My explanation on how to create this section was a little long, and if your code for this section doesn't work properly, please download the source code provided and use it. See you in the next lecture.